We've been trying to understand how the universe makes quasars, these most luminous sources in the universe, when a supermassive black hole is swallowing huge amounts of gas and dust around it. What we found emerging was completely different from what the standard theory has predicted for about 50 years, particularly that these central regions have vastly stronger magnetic fields than we had thought, or really that anyone had been predicting. And the magnetic fields are really the thing that's controlling the evolution and the fueling of these black holes. And the whole dynamics of this region around the black hole is regulated by these very, very strong magnetic fields. You're just trying to model a set of equations that are too complicated for us to solve pencil and paper. You've got gravity pulling things together, turbulence and fluid dynamics, there's magnetic fields, but there's also radiation pushing on the matter around it. And all of those are things that we think we understand the fundamental equations that they obey, but how they all interact non-linearly in this chaotic, messy system is the challenge. And so we use a computer to solve that by basically breaking up those equations into little pieces over some domain and just solve the same equation a trillion times to ultimately predict how this whole system is evolving. This movie shows the gas swirling in and falling onto the galaxy and the black hole, color-coded by, in red, where the energy is mostly in strong magnetic fields, and in blue, where the energy is mostly in heat. As you zoom in and reach the scales around the black hole, the standard theory predicted that all the energy should be in the form of heat, and that should be the dominant thing controlling the system. You see it's bright red. That means that the magnetic fields are actually the thing that's dominating and controlling the dynamics on those scales. Magnetic fields being so strong makes qualitatively different predictions from the theories that we've had for decades. So, for example, the magnetic fields can actually hold up material and prevent it from collapsing under gravity, so it's this thick ring of material around the black hole instead of being this flat disk. I like to believe that these simulations have an effect on how we understand the cosmos that we see, even if just to give us a better idea of how it all got there. How did we get something like the Milky Way? And where do these giant black holes come from?